All right, so let's share the screen. Hmm. Okay. Hmm. Let's see.
Oh, and I have a question.
Yeah.
Um, I logged into the ProctorU website and I was gonna schedule my midterm, but I didn't see it as an option.
Right. I haven't put it yet.
Okay,
I think I will do it tomorrow or Thursday.
okay.
Yeah.
Thank you.
So you've decided you're going to take it through ProctorU?
Did we have an option?
Yeah. Well, we still might have the ULM option.
Because isn't it next week that we have to take it?
Yeah, it is next week, and but you see, you just need 72 hours in advance. So by tomorrow, I will announce that what dates you will have. I mean, the dates I know it's going to be Monday and Tuesday for ULM, and tomorrow I will announce the exact times.
Okay.
Mhm. Okay. Yeah, and then after I announce that, then I will also put things on ProctorU. Okay, brief review.
Yes.
Okay. So match the linear correlation coefficient to the scatter diagram. So now you know that if R is -1, then that's a perfect negative correlation, right? And in that case, the points will be all on a straight line of negative slope. So now, like this one is perfect negative. So this is like R equals -1. But here I have R equals -0.523. So -0.523 is like kind of in between. It's not zero. Um, I mean, zero will be something like that, where there is absolutely no pattern, right? Neither rising nor falling. So this is a negative correlation, but not a very strong one. Now, this is also a negative correlation because the points are falling, but this seems quite strong as opposed to, well, actually, what would you say about this one? Are the points falling or is it just no pattern? I
I
just
mean, I would still say they were decreasing.
Yeah, yeah, this could be looked at in both ways. They could be decreasing, and the reason why I had second thoughts about it was that this looks too strong to be -0.5. This looks like closer to -1. So the only option that could be the -0.5 should be this B then, because this looks more like a -0.9 or -0.8. This is pretty strong. So, but I won't be surprised if this is not right. But okay, yeah. So I mean, you thought it better than I did. I was saying that this is no pattern, but this is like kind of negative. Mm, okay. So then, what does it mean to say that linear correlation coefficient between two variables equals 1? So 1 means it's perfect positive correlation, right? -1 means it's perfect negative correlation, and +1 means it's perfect positive correlation. And in perfect positive correlation, all the points lie on a straight line. So which one?
Um, is it A?
A says perfect positive scatter diagram would contain points that all lie on a line with positive slope, right? Suppose 27 cars start a race. In how many ways can the top 3 finish? So you know that it's either combination or permutation because you're selecting 3 cars out of 27, right?
Yes.
So now tell me, will the order matter in this kind of situation or not?
It would.
It would, because it's not
It's
just a top
3.
3, right? It's you want to be number 1, right?
Right.
So order matters, and if it order matters, what is it? Combination or permutation?
Permutation.
Permutation. So 27p3, 27 PRB. It's already on P, so 3. And that's 17550. For the month of December, 68% days are cloudy, 65% days are cloudy and foggy. What's the probability that a randomly selected day will be foggy if it is cloudy? So you know, you have that formula of A given B, right? So you have this formula, probability uh, A given B. But I don't see the word given here, but is it present in some other form? Is there a word which means pretty much the same thing as given? And you should look for it in the question part of the problem. What is the probability that a randomly selected day in December will be foggy if it is cloudy? Is there any word in this part which I can replace with the word given?
Would it be randomly?
That a given selected day? No, no,
Then probability?
no.
Oh, I have no idea.
What about this if?
If?
December will be foggy given it is cloudy.
Oh, okay, yeah.
Yeah, so you're given that
I
it's,
see it.
so it'll be foggy given. So what symbol did I use for given? This one? Foggy given cloudy. So what's the formula for the A given B?
Is it? I don't know if I wrote it down. Okay, I don't think I have this one wrote down. I thought it was the one where it would be like plus F plus C and
No,
then minus them, but it's not that.
that's for the or, that's for the A or B. So it's the section after that. You didn't write it down?
I don't see it in my notes.
I mean, it may not have the, I may have written it as A given B instead of writing this. This is a symbol for given.
Would it be the P and then F and C?
Right, P, F, and C. Right, divided by?
Divided by, and then I don't have what's under it. I don't know why.
Yeah, so you always divide it by what is after this given symbol. So here,
The C?
C, yeah, divided
Okay.
by P of C. That came out in a funny way. P has to be here, and how do I get rid of this one outside? Okay. So it's always divided by whatever is after this slash or after the word given. So F and C is how much in this problem?
68 and 65.
So which one is F and C and which one is just C?
Wouldn't C be the 68?
Right, that's just the cloudy. And the F and C is foggy and cloudy.
Which would be 65.
I mean, it doesn't matter whether you say cloudy and foggy or foggy and cloudy, it's the same thing. So 65 on the top, 68 on the bottom. So 0.65, 0.68 equals.
It would be 0.956.
Okay. Suppose that a local area network requires 6 letters for usernames. Lower and uppercase letters are the same. How many usernames are possible? Okay. So does it say that you cannot repeat a letter?
No, it doesn't.
Okay, so then it means you can repeat. So you have 6 letters. So how many choices do you have for the first spot? You can put anything of the alphabet in the first spot. So how many choices?
26.
Yeah. And then how many choices do you have for second spot?
It would be 26 again.
Again, 26. So how many 26s will there be?
It would be 6.
6 of them. And what is happening in between them?
They're being multiplied.
Because it's that and that and that and that. So 26 multiplied by itself 6 times. Which one?
B.
26 power 6. So now this is your E or F formula. So tell me, what's the formula for E or F?
It would be P, open parentheses, E or F. close parentheses equals.
Say again, what did you just say? Say from the beginning.
P, open parentheses, E or F.
No, E or F is on the left side. So what is it equal to? So P
Oh,
open
okay.
parentheses, E or F equals?
It would be P, open parentheses, E,
Right.
close, plus P, open parentheses, F, close, minus P, open parentheses, E and F. And isn't this when they have something in common and you have to like subtract it?
Right. And that's the, whatever is E and F, that's the common.
Okay.
Here it's 0.1. So tell me the numbers.
Okay. So it would be 0.30 plus 0.45
Right.
minus 0.30
Minus 0.30.
Okay.
Minus P, E, and F. What's P, E, and F?
Would you add them together?
Well, E, isn't this P, E, and F?
Oh, okay. I didn't see that.
Mm-hmm.
Yeah, so it would be minus 0.10.
Equals
Let's see.
6.5.
Yeah, that's it.
Oh. Tell me, why is it wrong? Because I have all this.
Oh, because you have all, yeah.
Okay, I did that in one of the videos also, where I wasn't able to spot what's going on. Okay. And also this needs to be erased.
Let's see what mine is.
Okay. Single card is selected from 52. What's the probability that the card is a club? So how many clubs do we have?
Oh, I do not like these problems because I don't know.
You don't?
I'm not familiar with a deck of cards.
Okay,
But
so
I'm
let's
pretty sure from the problems, isn't it like
go over it again. So all you need to know is
4 and then 13, right?
yeah, there are, so you know there are 52 cards total.
Yes.
Okay, so there are 13 clubs, 13 spades, 13 hearts, let's magnify this. 13 hearts and, come on, I'm writing uppercase H, and 13 diamonds. So, and then you have to know that the clubs and spades are black and hearts and diamonds are red. So let's do. Okay. And then you have to know that the composition, that how these 13 are made up of. So do you know how these 13 are made up of?
Of the 10 numbers,
Right. What are the numbers? They start from 1 or from 2?
it starts from 1 and goes to
No,
10.
actually, they don't have a 1. It's an ace. It's not a 1. It's an ace.
Oh, yeah.
They actually start from 2, 3,
Okay, starts from 2.
up to 10. And then So these are 9 of them, and what are the other 4?
It would be the king,
Mhm.
queen,
Okay. King, queen,
and then
jack, and ace.
yeah.
So card lovers will not like the way I've written this, because the usual order is after 10, it's jack, queen, king, and ace. But doesn't matter for your purposes. Who cares whether it's king, queen, jack, or jack, queen, king? And which of these cards are known as picture cards or face cards or code cards?
Mm,
These 3, the jack, queen, king.
okay.
So it's the same. Sometimes they will call them picture cards, sometimes they'll call them face cards, and sometimes they will call them code cards. Okay, so that's all you have to know. So now let's see. The question was, what's the probability of a club? So how many clubs?
13.
13 out of 52.
Yeah.
So what is 13 out of 52 in decimals?
Let's see. 0.25.
Right. The probability that the card drawn is club, given that the card is black. So now I mentioned in one of my videos that the given problem can either be done through the given formula, but many times in these word problems, there's another way which is sometimes easier. And the way is to think that whatever is given, that's your whole total. So given, what is given is your total. So normally, what's the total in a deck of cards?
52.
52. But in this case, we are given that the card is black. So in this case, the black cards will be the total. How many black cards do we have?
Just 26.
26. So in this case, you will not be dividing by 52, but you will be dividing by 26, because that's your total. So you can, what do we want? We want the probability that the card is a club. So again, we have 13 clubs, but we will not divide by 52, but by 26, because that's given. It's given that it's a black card.
Okay, I have a question.
Uh-huh.
On mine, instead of given that it is a black card, it says given that this card is court.
Yeah, so tell me, what did we say? Which cards are court?
Would it be out of the 3?
So
So
it's a jack, queen, and king that are court, right?
okay.
Agreed? So how many court cards are there? Would it be 3? No, no, no.
The,
Jack, queen, and king
there's
are,
4 of
yeah,
each.
there are 4 of them. So how many total?
12.
12, yeah, 3 in each suit.
Okay.
So in this case, you will be dividing by 12.
Okay. That makes more sense.
Mm-hmm. So what's the answer for my problem?
Um, 0.464.
What did you do? Tell me the 2 numbers that you divided.
Wasn't it 13 divided by 26?
Yeah.
I must have did something else. It's 0.5.
Yeah.
I don't know what I did.
See, that's the advantage of good mental math, that I can even spot the calculator mistakes.
Yeah.
Hmm. A woman has 6 skirts and 10 blouses. Assuming they all match, how many different skirt and blouse combinations can she wear? So she has how many choices for the skirt?
6.
And how many choices for the blouses?
10.
And what does and mean? What's the operation that I put between the 6 and the 10? And means?
Is it multiply?
And means multiplication, or means addition. So 6
Okay.
times 10 equals 60. %17% of population is hopelessly romantic. If two people are randomly selected, what's the probability that both are hopelessly romantic? So you want romantic and romantic, right?
Yeah, I saw that on the video and I just didn't quite understand it.
Okay. So you agree we want romantic and romantic? Both are romantic, right?
Yes.
So what's the probability of being romantic? One of them being romantic.
Oh, it would be 1 out of 2, right?
No, they give you it.
Oh.
So
Oh, 15%.
17%, right?
Okay.
So 0.17, that the first one is romantic. And means multiplication. And what's the probability that the second one is romantic?
Wouldn't it be 0.17?
Yeah. So equals 0.0289. Tell me, why did it count it wrong?
You forgot to take out the PRR in the equal sign.
All the explanation. Okay. What's the probability that at least one is romantic? So there's one thing which I've said repeatedly. How do we do the at least one problems? Through the what's the magic word? We always do the at least one problems through the I said you should remember it as a rhyme.
I'm not sure.
Okay, so think about it. So at least one means 1 or 2 or 3 or 4 and so on, right?
Right.
So what have I not counted in this list? There's an important number that is not part of this list that I just said. I said 1 or 2 or 3 or 4, so on. What am I missing?
0.
0. So 0 is the complement of at least 1. So you always do the at least 1 through the complement. So it would be 1 minus probability none romantic. is it putting E at a distance? So that's how you always do the at least one. At least one of something is equal to 1 minus probability none of that. Equals 1 minus. So now I want none of them to be romantic. So if the probability of being romantic is 17%, what's the probability of not being romantic?
Um,
So
I don't know.
probability of each person being romantic is 17%. What's his probability of not being romantic?
I really don't know. Don't you
Let-
put
Let's
something right there and then you whatever
let's
you
look.
get, subtract it by the 17?
Yeah, let's look at a simple problem. Let's say in a class, 10% are boys. How many are girls? 10% of the people in a class are boys. Then how many are girls?
If you're doing like 100 and 10% of boys, then the 90% would be
Right.
girls.
So what did you do? Didn't you do 100 minus 10?
Right.
So in this case, 17% are romantic. So how many will be not romantic?
So you would do 100 minus 17,
Right, equals.
83.
Yeah, so 0.83.
Okay.
So 0.83 will be that one person is not romantic. And what's the probability that second one is also not romantic?
0.83.
Yeah, so you agree that this, when I multiply the 2.83s, I get that none of them is romantic. None of the two is romantic. So what's the final answer?
Would it be 0.3111? And we have to take all that other stuff out.
Yeah. Hmm. A card is drawn from 52. Find the probability that the card is a queen or a club. Express the probability as a simplified fraction. Okay. So how many queens
4.
and how many clubs?
13.
Okay. So now is there an overlap? Can a card be a queen and club at the same time?
One of them.
Yeah, so there's an overlap. So whenever there's an overlap, if there was no overlap, you would just add the 4 and the 13 because you know that OR means addition, right?
Yes.
But if there is an overlap, then you do your formula for A or B. So you would do 4 plus 13 minus How many did you say was an overlap?
1.
1. So it'd be 4 plus 13 minus 1 equals?
Should be 16.
16. So 16 out of, don't look at the answers. So it should be 16 out of?
Out of 52.
16 out of 52. So
And then you
16, simplify it,
Okay.
16. So
4 out of 13.
right. There are 8 performers who are to present their acts at a variety show. How many different ways are there to schedule their appearances? Okay. So all the 8 have to perform, right?
Yes.
So you have to select 8 out of 8. And now, will the order matter, the order in which they perform?
No.
Really? I mean, wouldn't you be
Yeah.
offended if you are given the last turn, if you are one of the performers? And somebody who
No.
gets the first turn will be very happy. And also, depending on which order they perform, that may mean, let's say you like a certain person, then you will go based on which order your favorite person is performing, right? So order does matter. This is like a lineup. In any kind of lineup, order matters. So in
Okay.
order matters, it's permutation. So what is 8p8?
Um, 40,320.
Right. How many distinct arrangements of all the letters in the word football are possible? So do you remember the technique in this kind of problem?
We would count the letters.
Count the letters. How many are there?
8.
8. So then what do you do? So I was saying that if all these 8 letters were different, then the answer will be 8 factorial, right? But here they are not all different.
Right.
So you would still do 8 factorial in the numerator, but then you will divide out by something. What will you divide by? To take care of the repetitions.
Would it be 2?
So because there are 2 O's, so you will divide by 2 factorial, but there are also 2 L's.
So would you do 4?
Basically, you will divide by 2 factorial and another 2 factorial. So it will end up being dividing by 4. But it's not 4 because it's 2 and 2. It's just because 2 factorial is 2. So the way we write it, let me write it down correctly. So 8 factorial third equation. So it'll be 8 factorial in the numerator, 8 factorial, and 2 factorial in the denominator for the two O's, and then times 2 factorial for the two L's. And if something was repeated 3 times, then you would write 3 factorial for that.
So would you just do the top part and get the answer,
Mm-hmm.
and do the bottom part and get the answer, and then actually divide them?
Right. So maybe, yeah, let's make use of this calculator. I'm so happy that I found this thing. 8 factorial divided by, so how would I would do it like this, divided by, I'll put a parenthesis, and I already know that 2 factorial is 2, but if you don't know it, then you can just do it again and again. 2 factorial times 2 factorial again. Factorial. And that's how I will do it. Okay, so 10080. Suppose you toss a coin 100 times and get 89 heads and 11 tails. Based on these results, what's the probability that the next flip is a head? So it seems it's a very long-worded problem, but it's pretty straight answer. So if you have 89 heads out of 100, what's the probability of a head?
0.89.
Yeah. What did you do?
89 divided by 100.
Right. What's the probability that the first card is a spade and the second card is a spade if the sampling is done without replacement? So what's the probability that the first card is a spade? How many spades?
13,
Out
so
of?
52.
So that's the probability that the first card is a spade. And now I want the second card to be a spade, but it's done without replacement. So after I picked up one spade, how many spades are left now?
12.
And how many total cards?
51.
Yeah. So it'd be 13 by 52 times 12 by 51 equals. Point 0583, is it?
Yeah.
Okay. 0583.
It would just be 058.
Okay.
What, 59?
Is it 0.059?
Yeah, because there's an 8 behind it.
So you were saying it was 0.0588?
That's what I got.
Okay, so 0.059 then. Okay. If the sampling is done with replacement, so what difference happens if you do it with replacement? The first one is still 13 out of 52. What's the second one?
Would it be 13 out of 52 again?
Yeah, because you've just replaced the initial situation. So it's 13 out of 52 times 13 out of 52. 0.063.
Yeah, 0.063.
How many different simple random samples of size 5 can be chosen from a population whose size is 35? So, you're selecting 5 things out of 35. So it's either combination or permutation. So how do we decide if it's combination or permutation?
If the order matters.
But does the order matter? Is there anything to suggest that the order matters?
I don't think so.
Yeah. So if you don't see anything to suggest that, then by default, it doesn't matter. So combination then, 35C5, 35, and CR5. 324632.
Yes, that's what I got.
I think your calculator, it's also the same thing, right?
Yeah, it's just like a little different.
Yeah, your calculator is different, but I think the buttons are the same, right?
Yeah, it is.
What's the probability of obtaining 7 tails in a row? So what's the probability of getting 1 tail when you flip a coin?
Wouldn't it be 1 out of 2 since there's just 2 sides?
And then, and you want a second tail, so again 1 out of 2 every time. So how many 1 out of 2s am I going to write?
7.
7. So that's like saying?
A half to the 7th power.
Right, a half to the 7th power equals?
.00781.
Okay. A card is dealt from 52. Find the probability that it's not a 6. Okay. So how many 6s do we have in the total deck?
4.
Or we want it to be not 6. So out of the 52 cards, if 4 are 6s, how many are not 6s?
48.
How did you do?
Just 52 minus 4.
Right. So 48 are not 6s. So 48 divided by? What do we always divide by? In deck of cards?
52.
Yeah. So 48 divided by 52 are not 6s. So equals, simplify.
It gave me a decimal.
Do you have a way of simplifying it into a fraction? I know that's the kind of thing students know, but I always have to learn how to do it. So, but somehow students learn it at some point. I don't know where they learn it. So 48 divided by 52. So how do I get a fraction out of this? So I think it's one of these kind of buttons, the N over D and the U N over D. So let's try. So enter. So right now it gives me a decimal, but let's see what happens if I hit this button, N over D. No. Come on, a while ago you simplified a fraction like this.
Yeah.
Because the thing is, I can always do it so quickly in my head. I never needed to know how to do it on calculator. So how did you do it when you did it a while ago?
I don't remember.
Oh, look at this, F to D. Maybe it's this one, the F to D button, right? So, okay. So that's the decimal is 0.9. And now let's do second, F to D, enter. Ah, works.
Hmm.
Do you have that button on your calculator, F to D button?
Oh, I do. So second.
Yeah, for first do the decimal and then do the second F to D, and then that should do it.
Oh, it worked.
Does. Okay, good.
Well, that's neat.
So then I'll always be curious how you simplified that fraction earlier.
Yeah.
And you yourself forgot how you did that. Okay. So 12 out of 13.
Neat.
Let the sample space be 1 through 10. Compute the probability of an even number less than 9. So how many even numbers less than 9 do you see here?
Mm, 4.
Which ones?
2, 4, 6, and 8.
Okay, so 4 out of how many total numbers do we have?
10.
10. So 4 out of 10 is 0.4. So how would you do this? 6 factorial divided by 4 factorial.
With the calculator?
Okay. But do you remember a problem in the homework where there were very big numbers which the calculator was overflowing?
Oh, I do remember that, but I don't remember what we did
Okay.
about it.
So let's first see that since here the numbers are small, you can do it by calculator. 6
Mhm.
factorial. Divided by 4 factorial.
30.
What do you get?
30.
30. Now let's say that these were those huge numbers which the calculator was overflowing with. So the way you would do a fraction would be, so it was 6 factorial divided by 4 factorial. So what you do is you start opening the factorial out. So you know that 6 factorial means 6 times 5 times 4 times 3 times 2 times 1. And in the denominator, you do the 4 times 3 times 2 times 1. Now, if the numbers are very big, then of course you're not going to write all of them. You will just write like the first 3 or 4 numbers and then dot, dot, dot up to 1, right?
Right.
So no, whether you write all of them and whether you just write a few to sample out, you see what's going on. So you see this one from 4, 3, 2, 1 onwards is the same as this one. 4, 3, 2, 1, this part is just the same as this part. So wouldn't that 4, 3, 2, 1 and 4, 3, 2, 1 cancel out?
Yes.
And what is left over?
The 6 and the 5.
Yeah, so what do you get? 6 times 5 is?
30. Oh, okay, and that's what the answer was.
Yeah, and now this could be done even if this was 600 or something, right?
Okay.
So I like those big numbers very much because anytime the calculator breaks down, I love it. Yeah, because that means you still have to learn other things besides the calculator.
Yep.
Okay. The sample space for tossing 3 fair coins is this. What's the probability of exactly 2 heads? So how many total points do you see?
8.
8. And how many of these have exactly 2 heads?
4.
So 4 out of 8 equals?
1/2. Just kidding.
Ooh, you told me it's exactly 2 heads and I believed you. So tell me, which of the points have exactly 2 heads?
1.
So name the points. Which are the points which have 2 heads exactly?
Okay. The first.
The first has exactly 2 heads? H.
Oh my gosh. I was thinking like
At least
has
2. At least 2.
2 like in it.
Yeah, no.
Like has 2 in it.
No, that's why they use the word
Well,
exactly 2. So you should not have more than 2.
okay, so it would just be 3 then.
Yeah, this,
So it would be
and this.
3 out of 8.
3 out of 8. Okay.
Hmm. Okay.
So that's just calculator problem, 14C8. Yeah.
Yeah, that's easy if you know how to do it.
So which one is it?
I did mine. Let me do that one. So it would be B.
So 36 equally likely outcomes. Find the probability of getting 2 numbers whose sum is greater than 9. Okay. Can you spot how many of these are summing to greater than 9 means 10, 11, or 12? So how
Right.
many of these are summing to 10, 11, or 12?
Wouldn't it start with the 2 5s? Since that's
2 5s, how about this 4 and the 6? Isn't the,
Yep, that's 10.
yeah. So this one, and then the 2 5s, and then
It would be everything after that. Oh
really?
no. No, because the 6 and the 1
Yeah.
is just 7.
Yeah. So you have to spot which ones are there. So the 1, 2, 3, yeah. And then what's the next one after 5, 6?
The 6 and the 4.
Okay, so 4, 5, and 6. So 6 out of 36 equals
6. 6 out of 36 is 1/6.
mhm. A doctor wanted to determine whether there will be a relation between age and cholesterol. Draw scatter plots. How do you do scatter plots?
You go from the data, use the points from the data.
Okay. But you can also do it on StatCrunch, don't you?
Yes.
So how do you like to do it? By looking at it or by StatCrunch?
I do both, but we can do StatCrunch.
Whatever you like. If you can quickly spot it, then fine. Otherwise, StatCrunch. Now we have to do StatCrunch anyways for the other parts, so let's get started on that. Usually if it takes that long, then maybe you should do on StatCrunch.
Yeah, I was doing it on StatCrunch.
Okay. So what's the command?
Go to stat, then regression, and simple linear. And then you'll do age, cholesterol, and then compute.
Okay, and then you go to the second screen. All right. So what do you see there? A point, then it rises, and then it falls, and then it rises, and then so let's see. Okay. I hate it when it becomes so small. That's not helping. So just have to keep this in mind, this way, that way, there. And then just try to spot it. So did you spot? Which one was it? Then it fell. It looks like this last one.
Yeah.
Okay. And compute R, and R was there on that screen. So let's look at it. So R is negative 0.232. Negative 0.232. And then how do we answer this part? Does a linear relation exist? we compare it with the critical value, right? So how many data points do we have?
Uh, 5 from the chart.
Right, so let's see. So you will look at n equals 5, so the critical value is 0.878. So when do we have a linear relation? Do we need to be more than the critical value or less than the critical value in order to have a relation? So think of the critical value as a threshold, right? Yeah, yeah. Isn't it what?
Doesn't it have to be less?
It has to be more because it has to be more than that threshold.
Okay.
If you're below that, then it's not enough. So you have to be more than 0.878. So is it more than 0.878?
No.
No. And when we are doing that comparison, we just look at the absolute value. So no, which one?
Would it be D?
There is little or no evidence because the R is less than the absolute R is less than the critical value. Yeah.
I got something
Yeah.
wrong on mine.
What happened? Your scatter plot?
Maybe so. Let's see. Oh, I missed a point. Yep, that's what it was.
Hmm.
Okay. No, I got it. Yep.
So what do we do here?
Um,
Copy in StatCrunch?
yes.
And then the same command?
Yes, stat, regression, simple linear. And select the X and Y, then compute.
Okay, so where's the equation? This one, so they always give it backwards, right? Negative 4x plus 89.8, yeah?
Yes.
Negative 4x plus 89.8. That's a pretty simplified equation. I'm used to lots of decimals. Negative 4x plus 89.8. So remember, slope is the change in y for each additional x. All right, so you want me to write it down? Or do you have it memorized?
You can write it down.
Slope is the change in y for each additional x. And y-intercept is the y value when x is 0. Okay, so let's go back. So change in y for each additional x. So in this case, y is the final grade. So it will be the change in final grade for each additional absence. So which one?
Wouldn't it be the negative? Well, on mine it's negative. The 4?
So yeah, the slope is -4, but what's the interpretation?
Right, so wouldn't it be A, the slope indicates the average change in final grade for an additional absence?
Right, so change in y for each additional x. And what about the y-intercept? Y-intercept is the y value when x is 0. So y is the grade. So it'd be the grade with 0 absences.
Uh, would it be A, the y-intercept indicates the average final grade for a student with no absences?
Right. And where are my choices? Oh, something is different. Predict the final grade for a student who misses 2 class periods. Now, when they use the word predict, then you don't look it from here because I can see right away that for 2 class periods, it's 79.2, but that's the exact value. That's not the predicted value. So when they say predict, you always have to do it from the model, from the equation that you got.
And you just put 2 where the x
You put
is.
2 for the x. So it'll be 81.8.
And that's it.
Yeah, that'd be. So is it okay if we put it on YouTube, or would you prefer?
Yeah, that's fine.
Okay. Yeah, the only thing is YouTube, when it's such a long video, uh, I think I'll have to go through certain processes in order to get this approved. But this is actually, I mean, anytime there's a good student interaction, that's much better than me speaking alone. So this would be the most useful of all the videos that I have. Let's hope that it's not too much processes that you want me to go through.
Yeah.
Okay, so that's it.
Yeah, thank you so much for your help.
Okay, you're welcome.
Have a good day.
You too.